This is MSJ Chem. In this video, I'll be looking at the factors affecting the amount of product formed in electrolysis. We'll start by looking at the factors that affect the amount of product formed at the electrodes during electrolysis. They are the duration of the electrolysis in seconds, the current supplied in amps, and the charge on the ion. We'll also be looking at this equation, Q equals IT. Q is the charge in coulombs, I is the current in amps, and T is the time in seconds. 1 mole of electrons has a charge of 96,500 coulombs. Let's look at an example. A 40 amp current flows through molten iron chloride for 60 minutes. Determine the mass of iron and the volume of chlorine gas measured at 273 Kelvin and 100 kilopascals produced at the electrodes. So let's start by writing the equations that occur at the electrodes. The two equations are the reduction of the iron 3 plus ion and the oxidation of the chloride ion. From this half equation, we can see that 3 moles of electrons forms 1 mole of iron. And from the second equation, we can see that 2 moles of electrons forms 1 mole of chlorine gas. Next, we'll calculate the charge in coulombs using the equation Q equals IT. The current supplied is 40 amps and the time in seconds is 3,600. This gives us a value for Q of 144,000 coulombs. Next, we'll calculate the moles of iron and the moles of chlorine produced at the electrodes. To calculate the moles of iron, we divide the charge that passes through the electrolytic cell by 3 times the charge on 1 mole of electrons. The reason we multiply by 3 is because it takes 3 moles of electrons to form 1 mole of iron. When we do this calculation, we get 0.497 moles of iron. To calculate the moles of chlorine produced, we divide the charge in coulombs that passes through the electrolytic cell by 2 times the charge on 1 mole of electrons. The reason we multiply this value by 2 is because it takes 2 moles of electrons to form 1 mole of chlorine. This gives us 0.746 moles of chlorine gas. And finally, we'll calculate the mass of iron and the volume of chlorine produced at the electrodes. So for iron, we multiply the number of moles by the molar mass of iron, which gives us 27.8 grams. For chlorine, we multiply the moles of chlorine by the molar volume of a gas, which is 22.7, which gives us 16.9 decimeters cubed. Next, we look at electrolytic cells in series. Here we have 2 electrolytic cells connected in series. On the left, we have molten magnesium chloride. On the right, we have aqueous sodium hydroxide. So let's look at an example. 2 electrolytic cells are connected in series and the same amount of electricity passes through both cells. Determine the molar ratio of the products formed at the electrodes. Let's look at the equations that occur at the electrodes in the first electrolytic cell. At the cathode, we have the reduction of magnesium 2 plus ions to form magnesium metal. At the anode, we have the oxidation of chloride ions to form chlorine gas. In the second electrolytic cell, at the cathode, we have the reduction of hydrogen ions to form hydrogen gas. At the anode, we have the oxidation of water to form oxygen gas. By looking at the number of moles in each half equation, we can see that the molar ratio will be 1 mole of magnesium to 1 mole of chlorine to 1 mole of hydrogen to half a mole of oxygen. The reason we get half a mole of oxygen produced is that there are twice as many electrons in this half equation, which means that half the amount of product will be produced.